Skipper Diana and Navigator Davidson. We're setting sail into science. We've had so much fun. Now on the island, even after a shipwreck, hopefully you had a chance to watch last week's Acts 27 story time on the Wrightsville United Methodist Church YouTube channel. Just to remind you, my name is Miss Gina, and I'm a member of Wrightsville United Methodist, as are Davidson and Diana, and we have been volunteering at WUMC Vbs for a good number of years, maybe 10 or 12. And last week we had the pleasure of telling you the story of when Paul, the prisoner, warned the shipmates that the ship was going to crash, but that everyone was going to be okay. And we're so thankful that we jumped, aren't we? Because now we are A-okay. We're on the island here, as you can see, and we've decided it's time to do some science. So, what I recommend that you do is watch the whole video one time through and decide with your parent which one of the science labs that you would like to do on your own at home. Maybe you're only going to do one or two today and some other ones later. So watch the whole thing through one time and then go back and watch it again so that you'll know what supplies you need. So gather round and get ready for science. Okay kids, so remember, weight does not always equal density. Density is how much mass is in a certain volume of matter. Don't you ever wonder how that anchor can hold an entire big ship in place, even though the anchor is really small? Well, there is a lot of matter inside the boat's anchor. Just like a bowling ball feels really heavy because it has a lot of matter, but let's just say a volleyball or a basketball is approximately the same size as a bowling ball, but it doesn't feel super heavy because it doesn't have the same amount of matter. Well, today is all about density. Diana, can you hold up the definition of density? I want you guys to sing this with me. Density, density. How much mass is in a certain volume of matter? Density, density. How much mass is in a certain volume of matter? Okay, did you get it? If not, rewind it and try it again. Now you won't forget the definition of density. Well, we're going to make a density tower. And we're going to use some different liquids to prove that different liquids have different densities, even though they just look like liquid and they look similar. So we're going to use this little tower here. So let's talk about the different liquids we'll use today. Diana, can you pick up the vegetable oil? We have vegetable oil. Davidson, can you tell everybody what else we have?
Alcohol.
We have alcohol. And where is that yummy stuff? Ooh, there it is. Pancake syrup, okay? And you can choose your favorite kind. And then, of course, we'll have water, okay? And we can actually just use some of this water from our tornado tower since we've already got it made. Why don't you take that lid off and get ready since I've just colored myself blue here. Okay, so what do you guys think has the most density? Do you think it's the very sugary syrup, the oil, the blue water, which the color doesn't matter, or the alcohol? Let's find out. Why don't we start, let's make a hypothesis in a scientific method. We always have a purpose, a hypothesis, some materials, the procedure, and the conclusion. What do you think the purpose of this experiment is, Diana? To learn the density of different liquids. Davidson, do you have a hypothesis for which one is the most dense?
I would say syrup.
You think the syrup. Do you have a hypothesis of the next dense?
Oh, next probably oil.
You think oil. Okay. Do you agree? Okay. I think it's time for us to go into our procedure and then we'll learn our conclusion. Why don't you take a moment and make your hypothesis? Okay. What do you say we start with the water? Davidson, can you pour just a little bit of water in there? Maybe about to right here. We'll move those cans in a minute to make sure the kids can see. That's plenty. All right. And we might pour out just a tiny bit to make sure we have room for all of our friends to come in here. All right, you'll find out about these in just a minute. All right, Diana, why don't you pour the oil in, about this much, and let's see which one is more dense. And your mom might like for you to do this in your kitchen. Let's see. So I believe we had a hypothesis that water was lighter than oil, and we have proven that the oil is actually lighter than water, haven't we? Did you kids guess that oil would be lighter than water? Last year at VBS we talked about how we have a lighter spirit when we're closer to God, and we learned that oil is lighter than water. All right, let's try the alcohol. Davidson, why don't you add the alcohol and see what happens? This is why we have water that is a different color. Oh, that's pretty actually, isn't it?
It's even less dense.
It's even less dense. So, as you get older, you'll learn why the alcohol is actually less dense than the water. But let's add one more layer. All right, kids, this is the exciting part. Do you want to add the syrup, or do you guys, I think you both really want to add the syrup. You really wanted to add that syrup, didn't you? Okay, we're going to put this really, really yummy, rich, try not to get it on the side. Try to go right down the middle, because you'll get a really pretty, actually, effect. But, all right, set it down and let's see what happens. Oh my goodness. Davidson, why do you hypothesize that this oil is all, that this yummy syrup is all the way at the bottom?
It's like the most dense.
It's the most dense. Why don't you one time put some more syrup in there and try to go straight down the middle and see what happens. This time, kids, watch how it goes through. Yes, all right, that's good.
A lot of syrup.
That is a lot of syrup. Okay, so density. How much mass is in a certain volume of matter? There's more matter in the syrup, and I have a feeling that some of that matter might be sugar. What do you think? There's very little matter in the alcohol. That's why we use alcohol in our hand sanitizer, so that when we put it on our hands, it evaporates quickly, right? And we're not walking around with wet hands, and that would be dangerous to have it all over your hands wet as a child. And then here we have, what is this? Oil. And then here is just plain old water. Want to do something fun? Do you think that gas bubbles are lighter or heavier than these liquids here?
Well, I see some bubbles.
You already see some bubbles forming, don't you? Now, I don't know if that's a chemical reaction or if that is because we have a little bit of a sudsy effect going on. What do you think?
I don't think it's good.
All right, we're going to talk about chemical reactions a little bit later. We might as well throw in a little bit of the reasoning now. Okay, you need to come on back into the frame. Davidson, can you get the chemical reaction sheet over here? Since it's been brought up, there are 3 ways that you know you've had a chemical reaction. Number 1, do you remember?
Oh, the heat change.
A little bit louder.
Heat change?
Temperature change. Number 2,
Color change.
color change, and that does not include food coloring. And number 3, everybody's favorite, bubbles. If you mix 2 different liquids or substances and you get bubbles, temperature change, or what was the other one?
Changing color.
Changing color, then you have a chemical reaction. We're going to add one more substance here, and it's going to be gas. And we're going to find out what happens when you put gas in a liquid. Is the liquid going to be lighter, or is the gas going to be lighter? If you don't have an Alka-Seltzer tablet at your house, you have finished this science lab. But if you do have an Alka-Seltzer tablet or an aspirin, only with the help of mom or dad do you do the next part, okay? So, I'll give each one of you a piece. Matter of fact, let me get you a bigger piece for effect. And cameraman Ash, if you want to zoom in on our exciting little tower here, you can start dropping your gas bubbles. Go ahead and start dropping your gas bubbles in there. So the tablet itself has more density. and goes to the bottom. And if you want to zoom in,
Looks like a lava lamp.
if you want to come in closely and look really closely at your tower, your density tower, you will see that the tablet had more density than the liquids, but the gas produced by the tablet is lighter than the liquids, and so it's coming. The bubbles are
Actually, look, the tablet stopped right before the syrup.
and some of the tablets stopped before the syrup and did not even make it. That's a really good point. I don't know if your face needs to come over here. Davidson pointed out that the tablet never even went below the syrup. Kids, why is that? The syrup is more dense. And we're so thankful for the density of the anchor that held down that boat. And we're so happy that God can be a dense piece of our lives. He can be a lot of the matter in our lives. So let me see you kids take pictures of your own density towers. And you don't have to use all of these materials. You can just use 2 of them, whatever you have in your house. You can even try other materials like Gatorade or whatever you might have lying around. So take pictures of your density towers and post them to the Wrightsville United Methodist Church Facebook page or the Children of Joy Facebook page so that our director, Christina Norvell, can put them all together in her memory book. All right, now on to the next science lab. Okay, shipmates, this is our next lab here on the island after we've just had our big shipwreck. You know, I was thinking about that storm and how we need to show the kids how a storm is formed. And it has to do with cold air and hot air, but I can't show them the air because the air is invisible. So we're going to use water to demonstrate the different types of air. Okay, Skipper Diana poured some warm water here, and the purple represents the warm water. And Navigator Davidson, what did you pour?
Cold water.
Very, very cold water. I made my water a little too hot. You should make yours warm so that you won't get hurt while you're doing this lab. But you should still ask your mom for some help, right? Just in case the water gets a little hot. Yes, good job. If you have science goggles, go ahead and put them on. If you don't, you can pretend to put some on because this is not dangerous as far as chemicals, or you can put on some sunglasses. Okay, so we have here a separator, and we're gonna take a guess. Is the hot air or the warm air the catalyst in the storm, or is it the cold air? Let's find out. So first, I'm going to put this card on top of my warm air, or in our case, warm water. I'm going to come over here to the sink, just in case I don't get it exactly right. We're going to flip this over, and hopefully because of the surface tension of the water, it will not fall out of the jar. Let's give it just a second. And sure enough, we have created a vacuum. We're going to put our hot water on top of our cold water. Let's make sure we have it lined up exactly right. And then we're going to do the honors. Davidson, would you like to pull the card out from between the 2 jars? Be careful.
Well, I think so.
I'm holding it. Oh, I can't take any more. Okay. Do you notice, if you want to zoom in, cameraman, that the hot water is really not penetrating the cold water? Okay, remember we learned about density? We have more density in the cold water than we do the hot water. Now, do you have a hypothesis about what would happen if the cold water was on top of the hot water?
They would mix.
Do you think they'll mix because the cold water is more dense? Let's find out. Okay, shipmates, storm makers, we didn't get a storm last time. We had no movement in the water. And that's because we put what on top? Which one was on top last time?
Hot water.
The hot water. And because the hot water was less dense, it stayed on top and we had no movement, no storm. Well, I know you guys want to know how a storm is made, so we're going to reverse things. Which one do we think is more dense? Hot water or cold water?
Cold water.
You think cold water is more dense? Is your hypothesis that cold water is more dense? Let's find out, because if we put cold water on top of hot water and the cold water is more dense, it's going to move down and then we'll have a storm. Just like when the cold air and the warm air mix, there's movement, okay? All right, so Davidson's going to put a piece of cardboard on top. He's going to flip the cold water and explain to the kids why the cold water isn't going to come out when you flip it.
It's because the air pressure around it is all equal, so it keeps it in the same place.
A little bit louder.
It's because the air pressure all around it is equal, so it pushes the cardboard up, so it keeps it in the same place.
Okay. So now he's hold it up to the camera. That is his cold water, or we're pretending cold air. Now he's going to put it on top of the hot water. And Miss Diana,
Which way?
okay, Diana, let's not cover the front. This is going to be very fast. You're no longer going to have blue and purple. We're going to watch that bossy cold water do some movement when we pull the cardboard out.
It keeps ripping. Watch it, watch it.
All right, you hold it still.
Okay.
Hold it still.
How about this?
I got it this side. If Coco will just hold it still, I got it.
Oh, look how quickly. Did you see how quickly that cold water penetrated the hot water? Do you need to rinse your hands?
Cold.
Okay, she got so cold. So, she's being a good scientist and rinsing her hands anytime she gets a substance on them. And you guys saw how quickly the cold water penetrated the hot water, and you have made a storm. Now, normally it wouldn't happen so quickly because there's a lot of air out there, but this is just a demonstration. So can you try to have a cup of cold water and a cup of warm water? Color them different colors. It doesn't have to be purple and blue. It can be red and blue, or two of your favorite colors. And try putting one on top. Try, nothing will happen. Try flipping it, and you should get your own little storm. Ahoy, shipmates, and welcome back to Sailors Doing Science. We're so glad that you're here. You know, we've been talking a lot about how Jesus was resurrected and how we can't always see what's happening. God is always working in our lives, even when we can't see it. And I was thinking, let's look at all the creative things he does in our lives by looking at molecules and how they bond. Don't you think that would be the perfect way to tie today's scripture together with science?
Yes.
Yes. You know, they found Jesus resurrected that day, and how miraculous that must have been to be there and see that he was missing. And there was that empty tomb. And I'm thinking about all the times that we don't actually see what is happening, but it is happening. So, you know, for this one, we just need a few household items. You need some whole milk. I don't know if you want to point over here for a second. Some whole milk, any kind of dish soap, and some Q-tips. You also will need some fun food coloring. Any color is fine. As long as you have one color, that's plenty. But the more, the merrier. So we're going to pretend today that God is on this little Q-tip. And you know, he is everywhere. And it's really hard because we want to see God working in our lives. But I'm putting the Q-tip into the milk that's on my plate, and I don't see anything happening. But I know that it is. And even when I get some of the dish detergent and I put it in there, I don't see anything happening. And I really want to see some things. I want to see things happening. Well, this is milk that has a lot of fat in it. And fat and proteins. And we've got here dish soap, which is a different substance. We're going to take some food coloring, and we're going to let that represent all of the things that happen in our lives. And God makes us all so different and designs us in our own special ways. So I'm giving you guys these options to color your world a little bit, the same way that God colors our world. So each one of us gets to make our own individual design. So you just put a few dots of food coloring in your milk that's been poured on your platter. You can use a tea saucer, or you could use a salad plate. I love the color purple and pink, so I'm going to give myself a couple of pink dots here. And they look so pretty when you put them into the milk. Now remember, don't move them. We want to let God move in our lives. We're just going to put the colors in that we really love, okay? I'm going to go purple and green. When I was a little girl, my bedroom was purple and green. And I've always loved purple and green together ever since. You love pink and blue, and you like blue and green. Yeah, is that Chelsea? Is that a soccer team color? Okay, and you seem to like every color. All right, kids, after you watch us today, I'm excited to see the colors that you use in your plates of milk, of whole milk. I hope that you will send us some before shots and some after shots of this very lab. And I don't know if you need more of an aerial tilt to come in and see the before shots of what we have done on our plates, and we're not going to move them or anything like that. Now, what happens when we get our dish detergent and our Q-tips? I like to put a little bit in a beaker or a little jar. We're not going to do it until you press this pause. I'm going to put plenty of dish soap on my Q-tip that I'm pretending is God working in my life, in your life, in your life. And I'm just going to hold it, and then you're going to want to ask your mommy to get her camera and to get her record button ready, because you're going to want pictures of this. Okay, so we're gonna all do a countdown together in your homes and think about all your friends and how God is working in all of our lives right now. Even though we can't see it, we can feel it, right? So we're gonna hold our Q-tips up, and I predict that the fat molecules are gonna bond and that God is going to be able to move in our lives and move on our plates, and we'll be able to see it this time because of the colors. We couldn't see it last time because we didn't have colors on the plate, right? When we only tried it on the white milk, we saw no action. But let's pretend that the colors are all the chapters in the Bible that we read. And now we have all this wholeness in our heart. Are you guys ready? We're not gonna touch it, we're just gonna hold it in the air. 3, 2, 1. Look at how pretty they are. Oh, yes. Look how they just keep changing and changing and changing. Wow. Look at that one. How it's still moving. It's not even directly on top and it's still moving. That's fascinating. Okay, kids, did you guys have fun with this one? I hope that you were able to design your own molecule plate here, molecule motions. And I hope that you will post a picture of yourself with your beautiful design. Some people call this tie-dye milk. I hope that you will post a picture and show us what you were able to do at home. Okay, shipmates, welcome back to the Sailor Science Lab. We're over here on Bible Island having a great time together looking at different things in science to help us appreciate the anchor that is on so many of our boats. You know, the anchor represents God in our Vacation Bible School. We feel like we are grounded and we can be steadied by Him, even in the stormy seas, right? We can throw over our anchor and hold our boat still. We can open our Bible and we can learn about Jesus. So density is a kind of a confusing topic. How can density be different than weight? Well, we're going to show you right now. This is my favorite way to demonstrate density to kids and adults too. I have to be reminded of this. Well, you know, an anchor is not a very big item. It's only about this big depending on the size of the boat, but yet it can steady the boat because it has all that matter in it. Density is how much mass is in a certain volume of matter. Density, density, how much mass is in a certain volume of matter. Density, density, how much mass is in a certain volume of matter. They know the song. They're getting serious about science and not singing right at the moment. So I hope that little jingle will help you remember the definition of density, okay? So you have to know the volume, how much of a substance you have, and you have to know the mass, okay? We're gonna look at the volume of this diet soda and this regular soda. What do you have in your hand, Diana? Can you hold it up high for the kids?
Cola.
Diet Cola, and can you tell us how many ounces are in your can?
12 fluid ounces.
12 fluid ounces. And how much of your regular soda do you have in your can?
Also 12 fluid ounces.
So your volume is 12 fluid ounces and your volume is 12 fluid ounces. Okay, kids, we've just learned the volume of the cans is 12 ounces. And I have here a tank full of regular old water, okay? Davidson, would you please gently put your cola sideways into this large tank of water? And kids, do you hypothesize what's going to happen? They tell me they think it's going to sink. Let's see. Okay, and indeed it did sink. That's perfectly fine. And it could be upright, it could be sideways. It's kind of up to the can how it wants to land, but it definitely is sinking, okay? Now, let's take the Diet Cola and put it into the tank full of water. Oh my goodness, why is it floating? Why is it floating, Diana?
Because it doesn't have sugar in it.
What did you say?
It's less dense.
It's less dense and it doesn't have what's the
Sugar.
sugar? You told me they were the same volume. Blah. So one of them sinks and one of them floats, but yet they have the same volume. What's in the cola that's not in the Diet Cola?
Sugar.
Sugar. So your moms probably don't want you to drink a whole lot of sugar, right? And they probably don't want you to drink Diet Cola either because it's made with some chemicals that our parents usually don't want us to drink. But the reason we're looking at this tank full of water is to show you that items with the same volume can have different density because of the matter. So the next time you can't figure out why something seems this way, you can say, what's the matter? Density. Density is what's the matter. Density. How much mass is in a certain volume of matter. The wise man knows his states of matter, and the states of matter are solid, liquid, gas, and plasma. Solid, liquid, gas, and plasma. Solid, liquid, gas, and plasma. The states of matter. Materials. Diana, can you tell us the name of the material you are using?
Cornstarch.
Cornstarch. Okay. So cornstarch is a really interesting substance. We're going to mix cornstarch and one other substance. What is it, Diana?
Water.
Water. She's going to mix it up. And when you look at the state of matter of cornstarch, you can see that it's a powder, which means it's a solid. So stirring your cornstarch in with water can be kind of a tricky thing to do. And it may take a little help from your mom or dad or a friend. So as you can tell, Diana is stirring together her cornstarch and water. Can you do the same thing? Diana has successfully mixed cornstarch and water. You're going to want to use a disposable pan for this because you would not want to do that dish, okay? We're looking at our states of matter, and solid, liquid, gas, and plasma are pretty easy to identify. Ice would be a solid, water would be a liquid, evaporated water would be a gas, and plasma has to do with radioactivity, so we won't talk about that today. But what in the world is this? I can tell when I mix my cornstarch and water that it's very liquidy. But this is one of the most unusual substances on the planet. Now, this is very tricky, but it actually changes based on impact, which is completely different than most substances. Most substances are based on the temperature. For example, ice turns to water based on a different temperature. But cornstarch and water is based on impact. As you can see, Diana is digging very slowly into the cornstarch, and she is regretting it. She is regretting it because now her hands are so dirty. But after she cleans her hand, you're not going to believe what she's going to do. Diana, what do we have here?
This is called a
Okay, so what do you mean it hardens on impact? Diana, show us what happens. Would you go up to a bowl of milk and punch it? What would happen if you went up to a bowl of milk and you punched it?
Bad things. It would splatter all over you.
It would splatter, but what happens if we punch this liquid cornstarch and water? Wait a minute. Has Skipper Diana lost her mind? Why is she punching the cornstarch? Punch the cornstarch. Okay, now slowly dip your fingers into the cornstarch. So when she goes slowly into the cornstarch, she gets a liquid. But when she punches the cornstarch, or picks it up. All right, punch the cornstarch. Punch it. Woo! It's a solid when she punches it, and it's a liquid when she slowly reaches into it. Would you like a turn, Davidson? In a non-Newtonian substance, if you're a silly girl like Diana and you're reaching very slowly, you will get a liquid. But if you punch the cornstarch, Davidson, punch the cornstarch. It's a solid. What? He has punched a liquid. Davidson, did you just turn a liquid into a solid? No.
Wait,
Actually, you are experiencing a non-Newtonian substance. Oh my goodness. Now Diana's going to demonstrate if you... All right, Diana, gently touch the non-Newtonian substance. One time I demonstrated this by sticking my face into the substance, but I didn't put my face in there quickly enough. And you guys know what happened. All right, go and mix your cornstarch and your water and see that things are not always what they seem. And sometimes you just need to look at things a different way. And that's what reminds us of the resurrection of Jesus. He was in the tomb and then he wasn't in the tomb. He's in our hearts forever, right? All right, punch that cornstarch.
Well, how did it feel like it was going to be this stressful?
Ooh, non-Newtonian substance. Yes, yes, yes. Good job, kids. Where should they throw it away?
Throw it in the trash can, I guess.
Yes.
Yeah.